Here we have a parametric equation where x is written in terms of t and y is written in terms of t, but y isn't written in terms of x. So that's called a parametric equation, and t is our parameter. And we have a point A where t equals -1. So somewhere along this curve, there's a point A, and they want the coordinates of A. So this is really easy because we know the value of t is -1. So you just substitute that there and there to find x and y. So x would be -1 cubed minus 8 times -1. So that's -1 plus 8 is 7. And y is equal to -1 squared, which equals to 1. So the coordinates of A will be 7 and 1. 7 for x, 1 for y. So that's our point A. We're then told that the line L is a tangent to C at A. So at A, there's some line that has the same gradient as dy by dx. So that's the key. When you see the word tangent, that means the gradient is equal to dy by dx at the point A. So we can find dy by dx using the chain rule. Okay, so because it's a parametric equation, we're going to have to use the chain rule. So we'll say dy by dx equals dy by dt, that's the derivative of that, divided by dx by dt, which is the derivative of that. Sorry, so this is that, and this is that. So dy by dt will give us that, and dx by dt will give us that. So let's do that separately. So dy by dt is simply 2t, and dx by dt, that's the derivative of this, is 3t squared minus 8. And therefore dy by dx will be 2t divided by 3t squared minus 8. So this is dy by dx, but m, the gradient of the tangent, is equal to dy by dx at the point where t equals -1. Okay, so we can write that as 2 times -1 over 3 times -1 squared minus 8. So that's -2 over -5. So that's just 2 over 5. So that's the gradient of our tangent, the gradient of this line. So to find the equation of the tangent, we use the expression for the equation of a straight line, which is y minus y1 equals m x minus x1. Or you could have said y equals mx plus c. We can use that, or we could use this. This is sometimes an easier alternative. So m is the value we just found. Y1 and x1, we get this from our point A that we've already found. So 7 and 1. So 7 is the value of x, and 1 is the value of y1. So you've got y minus 1 equals 2/5 of x minus 7. And if you multiply both sides by 5, you've got 5y minus 5 equals 2x minus 14. And then you can rewrite that as, because they want it in a particular format. They want you to show that 2x minus 5y minus 9 equals 0. All right, so that's 2x minus 5y minus 9 equals 0. 2x minus 5y minus 14 plus 5, that just means minus 9 equals 0. So we've shown that that's the equation for the tangent. So the key was to find the gradient, and the gradient is dy by dx, and you replace t with the value that they gave you because they said it's a tangent at A, and we're told that t equals minus 1 at A.